All right, guys, we are looking at solving absolute value equations in this video. I'm going to make a part 2 where we talk about solving absolute value inequalities. This is section 1.7 in our textbook. All right, this is review. I just want to talk about what absolute value signs mean. I know that you guys know this, but I just want to reiterate it. What these bars are called would be absolute value, the absolute value sign. And if you take the absolute value of a number, the solution, the answer to that is just you have to make that number positive. So if it's already positive, leave it positive. And if it's a negative number, you make it positive. So if I ask for the absolute value of 108, you would just tell me, well, the absolute value of 108 is 108. Okay, it's just the positive of that number. That number was already positive, so we're good. If I asked for the absolute value of negative 108, well, that answer would just be 108. Right? You just take that number, make it positive. This question here, absolute value signs act in PEMDAS like parentheses, so we would do those very early. The absolute value of negative 108 would be 108, and then there's this negative sign out in front, right? So you take the absolute value of the number first, which would be positive 108, and then there's a negative sign out in front, so that would be negative 108. So obviously, as the title suggests, we're going to be working with absolute value, and I want to make sure that we have a good idea of that. So this is asking basically that same question kind of in reverse. So instead of saying, hey, what's the absolute value of 7? And then you would come up with the answer of 7, right? I'm asking what value of x makes this a true statement? So what number could I plug in for that x that when I take the absolute value of it, you get the answer of 7? Now, this is a little strange perhaps because we're going to get two answers. There's actually two things that we could plug in for this x that when we take the absolute value of it, we get positive 7. And I hope that you guys come up with 7, right? Because if you plug in 7, you take the absolute value of 7, which is 7. But keep in mind, when you have a negative number in here, and then you take the absolute value of it, it makes it positive. So also another answer to this question would be negative 7. I can take the absolute value of 7 to get 7, or the absolute value of negative 7 to get 7. Well, I have another question over here. What about the absolute value of what value of x would make the absolute value equal to negative 7? Now, hopefully you're tracking with me and you see that this is an impossibility. Okay, there is no number that when you take the absolute value of it, you would get negative 7 because absolute value basically means make the number positive. And if you make it positive, it'll never be negative 7. Right? So the answer to this question here would be something like no solution or not possible would work at this point. Okay. Now, if I had a negative sign out there in the original question, then I could make this work. But I didn't. I was just saying, hey, what value that when I take the absolute value of it, do I get negative 7? Well, there is that one. So obviously they're not all going to look like that. We are going to take a step higher in level of difficulty. But this, if you were to imagine a big X here, right, it's not going to be, but if you were to imagine a big X here, what value, when we take the absolute value of it, would we get 45? Well, this could equal 45, right? Because if this is 45, when I take the absolute value of it, I would get 45. Or whatever's in here could equal negative 45. Because when I take the absolute value of it, I get 45. So what you're going to end up doing for all of these absolute value questions is you're going to break them up into two different problems. One of them is going to equal 45. And one of them is going to equal negative 45. I'm going to explain that once again, why you do this. What you're saying is anything in here in this black box, if I can make that equal to 45, this will be a true statement, because then I would take the absolute value of 45 and it would be 45. Or if whatever is in here is equal to negative 45, I would take the absolute value of it, and when I take the absolute value of that thing that's in there, right, it's negative 45, take the absolute value of it, you get 45. So what does happen to be in there? Well, it's 5x minus 10. So I can set this equal to 5x minus 10 is equal to 45, or 5x minus 10 is equal to negative 45. Let's take a second just to reiterate this. What did we do? We took whatever was in there, and we set it equal to 45, and we set it equal to negative 45. Now we're going to solve each of these equations, and we're going to come up with two answers. This should be pretty simple at this point. This is solving two-step equations, reverse PEMDAS, that side map order. You would first add 10 to both sides, so you would have 5x is equal to 55, so x is equal to 11. And over here, you would add 10 to both sides. Adding 10 to negative 45 is actually negative 35. And then divide by 5, x is equal to negative 7. Now, I am going to get kind of fussy with you at some point in this lecture, where you have to check your work. Okay, so let's make sure that we can do that right now. We want to make sure that when we plug in 11 in for x, then take the absolute value of it, we get 45. So if I plug in 11 here, 5 times 11 is 55, and 55 minus 10 is 45. When you take the absolute value of 45, you do get 45. This worked. Now let's try negative 7. If you plug in negative 7 in for x, you do 5 times negative 7, which is negative 35. And negative 35 minus 10 is negative 45. Your last step is to take the absolute value of negative 45, and that would get you 45. So both answers do in fact work. This question is very similar, and we've kind of hit on this earlier, but back here, remember when I said, hey, if you take the absolute value of x, would you get negative 7? And we came up with no solution. Okay? You're never allowed to take the absolute value of a number and get negative 7 out. That's what's going to end up happening here. We're never allowed to take the absolute value of something, whatever this is. It should never be negative 45, right? Because those absolute value signs, whatever it happens to be, are going to make it positive. However, this question here does have a solution. They're going to start to get more complicated and look a little bit like this, where the absolute value bars are not by themselves. So step one would be to solve for abs value. Okay. Step one is to get the absolute value signs by themselves. And you're going to do this much the same way that you just solve any type of equation. You're just going to kind of be like, hey, I want to isolate this. I want to get this whole thing here by itself. It has a minus 90 attached to it. How can I undo that minus 90? Well, I need to add 90 to both sides. So then I have 5x minus 10 is equal to 45. And this has absolute value bars around it. And then this just becomes this question. It doesn't come to that question. But yes, it does. Then it becomes this question here, right? Where we broke it into two different problems. We were able to solve the answers. We know what it's going to be. It's going to be 11 and negative 7. This question is very similar, or at least similar level of difficulty. Your first step, okay, the absolute value signs are not by themselves. They need to be. Okay, you need to move everything else to the other side. Currently, the absolute value bars have a multiply by 3 with them. The way that we undo a multiply by 3 is to divide by 3, and if you do it to one side, you do it to the other. 81 over 3 is 27, and this multiply by 3 and the divide by 3 cancel, so we still have absolute value of 2x minus 3. Now we have the absolute value signs by themselves, right? Absolute value bars are by themselves, and they're equal to something. Now is when we break it into two different problems. One equal to the positive number, which is just 27, and one equal to the negative number, which is negative 27. I'm going to tell you a mistake I see all of the time. People don't switch the 27. They switch this sign. One will be negative, one will be positive. That's going to get you the wrong answer 100% of the time. So what you change is the number on the other side of the equal sign. You make one positive and you make one negative, and then you solve for that. In this part, you would add 3 to both sides, and you would get 2x is equal to 30. So x is equal to 15. Same thing over here. You would add 3 to both sides. You get 2x is equal to, when you add 3 to negative 27, you get negative 24. So x is equal to negative 12. I warned you that I would be getting fussy about checking your answers. I'm still going to check this one. When I plug 15 in for x, 2 times 15 would give me 30, and 30 minus 3 is 27. Now I have to take the absolute value of 27, which is just 27, and 27 times 3 is 81. I need to do that again with the other answer. The other answer I came up with is negative 12. 2 times negative 12 is negative 24, and negative 24 minus 3 is negative 27. When I take the absolute value of negative 27, that actually gives me positive 27, and 27 times 3 is 81. So both answers work, and I need to include both of them, circle them, do whatever, because the next problem is going to have a kind of a difference here. So this next problem is going to be where we start to talk about this idea of an extraneous solution. And extraneous solutions are going to happen about once a chapter, and there was something we kind of skipped in Algebra 1 all of the time, and maybe alluded to perhaps, but extraneous solutions are times when you do everything correctly, but you still get a wrong answer. So all of your work was right, you made 0 mistakes, but because you listened to Mr. Nyquist and Mr. Nyquist is trying to get you to check your answers, you check your answer at the end, and maybe one of them works, maybe neither of them actually work, even though you did every step correctly. Okay, that's going to start to happen, like I said, once a chapter, and it's going to be something that even like if you're, even if you're good at math and you were like, oh, the teacher's always saying check your work, but I never like to check my work because I know I did everything correctly. Even if you do everything correctly, you still might get the wrong answer in these situations. I'll try to tell you when they might happen, but you need to get in the habit of checking your answers. So with absolute value equations like this, when you start to see potentially extraneous solutions is when you have an equals, so absolute value equals, and then there's an x or a variable on the other side of the equal sign, like this problem here. Your first step, much the same, is to isolate the absolute value signs. So get those by themselves. Move all the other stuff. Remember, here there was a 3 in front of it. Here there was a minus 90 after it. Much the same. We need to isolate the absolute value signs. This one already is. So then we can move on to step 2, which is when you break up the problem into 2 different ones, right? One of them equal to the positive 3x, and one of them is going to equal negative 3x. So 2x plus 5 equals 3x, and 2x plus 5 equals negative 3x. So, like I said, the fact that we have a variable over here, x on this side as well, is what creates the potential for extraneous solutions. So now I need to start solving this guy and this guy. I'm going to subtract a 2x onto this side. So I have 5 is equal to 1x or x. So 5 is one of my potential solutions. I don't know if it actually works yet. And over here, I'm going to start solving for x as well. I would subtract 2x here. If I do it to one side, I have to do it to the other. 5 equals negative 5x, so x is equal to negative 1. So my 2 potential solutions are 5 and negative 1. Let's go ahead and check them. If you plug in 5, 2 times 5 is 10, plus 5 is 15, and the absolute value of 15 is 15. And when you plug in 5 over here, you also get 15. That worked. So 5 is a valid solution. I'm going to check -1 next. If you plug in -1, 2 times -1 is -2. And -2 plus 5 would be +3. Then you have to take the absolute value of +3, and that just makes it positive. It was already positive, so it's just 3. Now you have to plug in -1 to the other side, and you do not get 3, you get -3. So -1 does not work as a solution. Okay? Even though we did all of the right work, we got an incorrect solution. Now, do not make the assumption that because it's negative, that's the reason why it didn't work. Okay? That does play a part, that might make it more likely, but we were getting negative answers, right? And they worked. So you do have to just check your work here and make sure that your answers are valid. It's a great habit to get into to always check your work. But the ones that you have to are when you have absolute value signs is equal to something that involves x. That is all we have for solving absolute value equations. I'll make another part for the inequalities for section 1.7.